Guys, today I will learn you how we can solve the unsolved homework. I'm talking about Hooke's law. How your question will be like that. For example, I can say calculate the K force constant of this spring according to the column below, or I can say let's calculate how much newtons you need to conjugate stretch or stretching to 1 centimeter or 1 meter, 50 centimeters, I don't know. Can be seems like that, okay? According to the column below, at first, the mass will be here, 0, 100, 200, 300, according to 500 grams. But like I explained in the class, mass is different from weight. Mass, that's mean kilogram, gram, okay? But weight, it's unit, the right unit to the weight is Newton, like the force. That means force and weight are the same. Let me explain that. How 100 grams equal 1 Newton. From this equation, from the simple equation, 1 kilogram of force equal acceleration multiple 1 Newton. That means we can calculate 1 Newton how much equal how much. That means 1 Newton equal 1,000 grams divided on acceleration. By that will be approximately 100 gram, not specifically equal 100 gram, okay? That's important. And the other, we can say 2, 3, 4, 5 newtons, okay? But the first one is important to explain to me, 1 Newton equal approximately 100 gram, how we could how we could determine, calculate these results from where it came, okay? Now let me go directly to the curve and the relation between delta L, the extension of the spring at y-axis, and the other will be at x-axis, the force or weight with Newton units. Let me decrease the screen a little bit. Here. A little bit more. Yes, here it's better. At x-axis, I said let's be each 2 centimeters at x-axis equal 1 Newton to be like that. And at y-axis, I said let's be every 2 centimeters and half centimeters equal 5 centimeters of stretching to be like that. And after that, 3.6, 8.6, 13, 17.4, 22 centimeters stretching. Let's plot the slope by put a line, make this line approximately through from all these points. Here I have a regular point from O to A, like the curve at the theoretical lecture at previous week when I said 0A, this point name is the proportional, here elastic limit, C and half E, the breaking point, here the fracture point. At this experiment, we test the curve from O, can say O, to A. This belongs to Hooke's law. That's like how the material will act against any load will be like any spring, okay? The same behavior with different results, sure. Here at this lecture, I'm illustrating the math side of the Hooke's law and how we can calculate the K constant of the spring. Here, when I say this point is the proportional point, that means we still at the elastic region, and we can check that when unloaded the weights, the spring must come back to its original length. Here, now let's talk about the functions. by the purpose number one to verify Hooke's law. F with a Newton, that's mean force, equal minus KL. K is the force constant of the spring, L the stretching. This is equation number one. That's mean when you need calculate the K constant to any string, that's mean K will equal force with a Newton divided on length with meter or centimeters. That's depend on your results. Now, from this curve, here I can't find the K force constant from this equation because I have 5 results of F, and the same thing with the L stretching L, I have 5 results. By that, I can't use this equation, but I have another solution, the plot, the curve. I can use slope from the triangle rules, slope equal delta L divided on delta F or weight, doesn't matter. If we take a look to equation number 2, slope equal delta L divided on delta F, this equation number 3. Let's take a look to number 2. We will find K equal reverse the slope. By that, by calculating the slope, we can find the specific result of K constant of the spring. Slope equal 4.46. By that, reverse this number, I have dot 22 for Newton to each centimeter. Let me read it again. That means I need dot 242 Newton to can gauge stretching equal 1 centimeter. If I say let's calculate it to each meter, that means I need 22.4 Newton to can gauge stretching equal 1 meter. Okay. Conclusion, the relation between them, it was linear relation. Its kind is direct. That's it. Thank you for your watching or listening. Have a good day and see you at next video.